In this short video, we'll look at block diagram reduction. So what's a block diagram? The block diagram is the schematic of the dynamic system with signal routing. Here is an example of a block diagram. Now these individual blocks here, they represent transfer functions of individual components. So for example, G2 could be the plant, this point 5 could be a sensor, G1 could be the controller, and this block here, which is a 3, is a feed forward transfer function. So when you're working in a company, for example, various groups will work on various blocks. So there might be a team doing the modeling of the plant, there's a team doing the modeling of the controller, there's a team that is selecting sensors, and what block diagram does is puts all of these things together so you can analyze the whole system. Now the goal of block diagram reduction is to take a complex block diagram that is shown here, for example here, and convert it to a transfer function. As you may recall, the transfer function is the relationship in the Laplace domain between the output and the input. Now you'll use this transfer function later to analyze the performance of the entire system. We will look at basically two methods to do block diagram reduction. The first one that we are going to look at is the brute force block diagram reduction method. So there are a few steps that you need to follow. First step is you need to trace the forward direction of the signal from input to output. When you encounter blocks in the path, you multiply the transfer function of the blocks with the signal, and in the end you'll get an equation that relates the output in terms of the input, and from that equation you can derive the transfer function. Now let's look at a simple example and then we'll go on to a more complex example. Now let's look at this simple system. In the forward path you have two transfer functions g1, g2, and in the feedback path you have g3. Now as I said before, you just follow the signal from the input to the output in the forward direction as this light green arrow shows. Now let's start from here. Here the signal is R, then there is a summation block. You go forward, the question is what is the signal here? The signal here is R minus whatever comes in through here. So we don't know what this is yet, we'll look at that later. So that's R minus X. Now what is X? X is the signal there. What is X? You trace back, it is the signal here going through this block. So the signal times this block, and that signal is Y because it's picked off from here. This is Y, so this is Y here. As you go forward, X will be G3 times Y. Therefore the signal here is R minus G3 times Y. Now you go forward again, you cross over G1, so you need to multiply G1 with this signal here, and therefore the signal here is R minus G3Y times G1. Now let's see what the signal here is. So the signal here is the signal at this point multiplied by G2, which is equal to R minus G3 times Y, G1, G2. Now incidentally this equation, this signal here is also equal to Y, so you can write down that equation and then you can simplify to get your transfer function out. Here we're looking at a more complex example of block diagram reduction with brute force. So in this example you can have a controller here, you have plant, a feedback, in fact two feedback paths and a feed forward path. So you're going to follow this green arrow and go from the input to the output. So let's start right here. Signal here is R. The question is what is the signal here? The signal here is the signal R minus whatever comes through here. Now that signal is C because you're picking off C from here. Now what's the signal here then? Therefore that signal is R minus C. You go forward through G1, therefore the signal here is G1 times R minus C. Now we want to go forward here, but we have two more signals coming in. through this summation block. Question is, what's the signal here? That signal is 3R. So R goes through here to this block, which is 3, gets multiplied 3R. So therefore this is 3R. Similarly, the signal here is 0.5 C. Signal here is C, goes through the 0.5 block. The signal is 0.5 C here. The signal here is this signal plus this signal minus this signal. So that is 3R plus G1 times R minus C minus 0.5 C. Now you go through G2, need to multiply G2 with the signal here, and then we get signal here is 3R plus G1 times R minus C minus 0.5 C, the whole thing times G2. Now this signal here also happens to be equal to C. So we can write this equation for C, and by simplifying we can get the transfer function like so.